Hello everyone, it's really good to see you here. So today we are going to solve a GFG problem, which is find position of set bits. So what we have to do, we have given an integer n having 1 ones and all other zeros in its binary representation. We have to find the position of only set bits. So if there are 0 or more than 1 set bits, the answer should be -1. So let's suppose we have given an integer n and it is given that if that integer n has only one set bit, then we have to return the index of that set bit. Otherwise, if it has less than 1 or if it has greater than 1 set bits, then we have to return -1 as our answer. So this is the problem statement. Now let's dive into its approach part. So here let's suppose our n is 8. So what we can see here is that n can be represented as 1000 in binary representation. So what we have to do is we have to consider two things. First one is C, which is going to count the total number of set bits, and K is total number of iterations. And what we do, we firstly take and with 1, so here we get 0. Now what we do, we just right shift our n value, so now our n is 100. So in this case our iteration is 1 and C is 0 because we don't found any set bits. Now what we do, now we again run the loop. So here 100 and 1 we got 00. So again the iteration would add up to 2 and our total number of 1 or total number of set bit as 0, and then again right shift our n. Again we take it and with 1 we got 0 and we got k as 3 and c as 0, and uh, right shift operation of n should be 1 now. So again when we take 1 and 1 we got 1, right? So here the answer is 1, and then here the k value increases to 4 and the count is equals to 0. So now what happened is that our n value is 0. So in this case, when the number of set bit is 1, n is 0 and our k is 4, so we have to return this 4 as our answer. Now let's try to do something like this. So here we can clearly see that this n equal to 6 has 2 set bits, right? So what we do, we firstly take and with 1, we got 0 and our set bit is 0, k is 1. Again we make the second iteration. Now k is equals to 2, and then we take and with the right shifted of this 1 we got 1 and when we take and with it we got 1. So now our total number of set bits increases to 1. Now again if we left shift this particular n we got 1, right? And when we take 1 and 1 we got 1. So here also we can now increment the count of our total number of set bit as 2 and our k as 3. So in this case you can see that this total number of set bits is not exactly equal to 1 because it is greater than 1. So we have to return -1 in this case. So this is the overall approach which we have to actually uh, implement in this code. So let's try to code this up. So here k is 0, which is basically counting the total number of iterations, and c is basically 0, so it is count total number of set bits. So now what we do, we just run a while loop till our n is greater than 0. Each time we have to increment our count whenever there is a while loop successfully runs. So if our n and 1 is equal to 1, we have to increment our c as it will count the total number of set bits. And if our c become greater than equal to 1, we have to break from there because in that case we have to simply return -1 as our answer. And each time we are done with this, we have to actually make our n right shifted by 1. So at the end we have to simply return this. So we are going to check an if else condition. So if our c is equal to 1, we have to return k, otherwise we return -1. So let's try to summarize this up. So this is the solution for the problem, find position of set bits. And if you want to access the code, then you can check the GitHub link given in the description. And before that, do like, share, and subscribe to this channel. And this is it for this.